So we're going to go over the quotient rule here, and we're going to use something that I am dubbing Jace's organizational chart, because he came up with this really awesome way to organize this so it doesn't get overwhelming for us. So when we have a quotient here, like we have in this questions, g of x equals f of x over the square root of x, Jace likes to think of this as, let's call the top u and the bottom v, and use that organizer that's associated with the definition. So what Jace does is he comes along the side here and he gets a space set up for u and u prime and v prime, and then he dumps everything in here and uses this as an organizer. So for instance, u, we know u is the top, and so the top evaluated at 4 is -8, so we'll put that in there. And then the derivative, u prime, is 5, so we'll put that there. And then the bottom is the square root of x, and we know that the square root of x is, if in our brain, if we think about that, that's like x to the half power. And so then we can differentiate it in this organizer, and it makes our it makes it easier to figure out the answer for the derivative of that quotient. So we're going to take a derivative here, v prime, so bring down the half x, and then we got to come up with a new power, right? We have to subtract 1, so little secondary brain here. When I have to subtract 1 from a fraction, I always think of doing that as like 1/2 minus 2/2. That makes it easier to find that new power, which is 1 smaller than the old power. And then so we know we have to evaluate these when x is equal to 4. So we know then that we are looking at the square root of 4, which equals 2. And then for this bottom one, we know that -1/2 power means I'm going to put the square root in the denominator, which means it's going to be 1 over the square root of 4, which ends up being 1/4. So now we have our 4 values here. I'll highlight them. We've got our 4 values here that we have to put into our definition of the quotient rule. So using Jace's organizer, then what we can do is we can just say, well, the derivative g prime of x is just that generic derivative from our definition, right? It's low d high minus high d low. So low d high minus high d low all over low squared. So that's really nice that we can just bring back the general definition of the quotient rule, and then we can just throw the values in. So I know v is 2 and u prime is 5. Got a minus sign there. U is -8, and v prime low d high minus high d low. Whoops, I forgot my prime up there. Sorry about that. V prime is 1/4, and that's all over v squared, which is 2 squared. So it makes that definition of the going back to that definition makes that quotient a lot more easy to get the answer to. So what do we have here? We've got 10 minus a -2 over 4, right? And that ends up being 12 over 4, which is 3. So I thought that was a really cool organizer that Jace thought up of, and so I wanted to show you there. I'm going to keep going, and I'm going to do the other the other quotient rule that was really similar to this, which is just below this. Just because it has a cubed root that we have to deal with, which is a little more computation as far as figuring out the values. But so that's why I'm going to do that. Okay, so if we look at this next one here, so we're going to use Jace's method here. We're going to call the top u and the bottom v in accordance to our definition. And then we're going to go u equals and u prime equals. We're going to organize everything here. V equals and v prime equals. And you can really do this with with any of the problems that we have here. You could even do it with the product rule too. Okay, so we know when we're evaluating this at x equal to 8. So the u then is f of 8, so that is 12. That's the function value at 8. U prime is the derivative, so that is 7 when it's evaluated. All right, so now we have to come to taking the derivatives. Okay, so we have the cubed root of x, and that is really x to the, I guess I'll get my brain out here again, right? If we think about that, that is x to the 1/3 power. So doing the derivative on that power, I bring down the 1/3 x. Thinking over here again in my head, a little detour. So now I'm thinking, okay, new power, 1/3 minus 1, right? Well, not really minus 1, because it's tough to think of that and get an answer. So I think 1/3 minus 1/3 minus, come on. Okay, I'm having some technical difficulties here. Let's see here. There we go. 1/3 minus 3/3. That's really what I need to think about. So that gets me a negative 2/3. So negative 2/3 for my new power. So now we have to evaluate those at 8. So to get our values. So let's see, I can probably squeeze this in here. I'll use a different color. Let's use red. No, let's use green. Okay, so the cubed root of 8, right? That's like another brain over here. That's like something times something times something equals 8. So we know that that is 2. Okay, now this is the one that gives people headaches. So I have 1/3, and then I have x to the negative 2/3 power. And so when you have that, you have to think, so this is going to be 8 to the negative 2/3 power. You have to think of that in 2 steps. So a lot of thinking here. So let's think about this. First of all, let's think about it as the cubed root of 8. Okay, right? I've got the 3 in the, I'm going to make my 3 a little more nicer written here. I've got the 3 in the denominator, so I know that's a root. Okay, so we know the cubed root of 8, like above, is just 2. So I really have 2 to the negative 2 power. So this is really 1/3 times 2 to the negative 2 power. And we know that the negative 2 power, I'm running out of space in my brain here apparently, 2 to the negative 2 power is like 1/2 squared, right? We can move it to the bottom and make it a positive power. So that's 1/4. So this is really 1/3 times 1/4, which is 1/12. Like I said, it was a little more thinking. But we finally got there. Okay, so again, the nice benefit here is that we can go through here and we got all the values we need right here, and we can just plug those into Jace's shortcut then. So we're going to go ahead and write that definition. G prime of x equals low d high minus high d low. So in terms of our v's and u's, low d high minus high d low all over low squared. And then I can just grab all my numbers. So we know v is 2 and u prime is 7 minus u is 12 and v prime is 1/12 all over v squared, so 2 squared. So we end up having 14 minus 1 on the top, all over 4 on the bottom, so that's 13/4 for g prime of 8. All right, so I hope you find Jace's method super useful. I think it's really cool. And if you have other awesome ways to approach these problems that make organization easier and help with the methodology, please let us know so we can get them out there so everyone can use them.